Welcome to Chapter 7 of the Shapley Values series. In this chapter, we want to look at how Shapley values are applicable to machine learning forecasts. Let's dive right in. So we now know how Shapley values are used in cooperative game theory. But what does that have to do with explainability of machine learning forecasts? Here we want to know how each feature contributes to the final forecast. It turns out the formula for the contribution of players to the payout in cooperative game theory only needs to be adjusted a little bit to reflect the machine learning forecast use case. In the game theory use case, one sums over all subcoalitions S containing a number S players but not player I, and in the machine learning forecast use case, one sums over all model feature subsets S containing a number of features S, but not feature I. Remember the simple machine learning model consisting of features for price, inventory, events, and temperature. If we wanted to understand the influence, that is, the Shapley value of temperature, we would just sum over the marginal contributions of temperature to the possible feature subsets S that temperature can be added to. For example, the temperature feature could be added to a feature subset S consisting of prices and inventory, or to a feature subset S consisting of prices and events. Note that we in fact use specific feature values such as 10 degrees Celsius or 100 pieces for the inventory level. This is because Shapley values provide local explainability, that is, explainability for a specific forecast for specific feature values. Next, the game theory use case calculates the weight of the feature's contributions as the number of ways the subcoalition S consisting of a number S players can be formed from all N players. In the machine learning forecast use case, the weight is calculated as the number of ways a subcoalition S consisting of a number of S features can be formed from all N features. In the simple model example of N equals 4 features, for example price, can be added to a subset of S consisting of inventory, events, and temperature in 6 different ways. Therefore, the weight of the price feature's contribution to the feature subset of S equals to inventory, events, and temperature of size 3 out of the total of N equals 4 features is 1 divided by 4. Lastly, the game theory use case calculates the marginal contribution of player I to a subset S by subtracting the payout for S without player I from the payout of S including player I. Similarly, for the machine learning use case, the marginal contribution of feature I is calculated by subtracting the prediction of f sub s of a model that was trained on only features x sub s excluding feature I from the prediction of a model f sub s including feature I that was trained on features x sub s including feature I. So this is how the Shapley value formula from cooperative game theory is applicable for explainability of machine learning forecast.